Today we're going to go over the properties of logarithms. So let's go over the basic properties first. This first one, b to what power? B to what power would give you 1? 0, because anything to the power of 0 is 1. B to what power will give you b again? 1, because anything to the power of 1 is just itself. So guys, go ahead and answer these two questions using the property we just went over. What should this be? 0 and 1. Okay, now let's go over the product property. Product means multiplication, okay? So we have two things being multiplied. The product property says that log of base b of n plus log of base b n is the same thing as this. You can rewrite it as this whenever you have a product. So let's go back and forth between these two formats when it's being multiplied and when you have two separate logs and they're being added. Let's go back and forth. So first, let's condense it. So when I say condense, we're going to turn it into one log instead of two different ones. So I'm going to use this property. I'm going to do 8 times 3x, which is just log base 3 of 24x. Now I'm going to expand it to make two different natural logs. In order to do this, I need to factor first. So can you guys think of two numbers that will multiply to -2, but add to give me -1? -2 and a +1. So this can be rewritten as the natural log of x minus 2 times x plus 1. Okay, now let's go ahead and use the product rule. The product rule says when I have two things multiplied, I can write two different logs and add them. So this will be the natural log of x minus 2 plus the natural log of x plus 1. The next property is the quotient property. When you see the word quotient, you should be thinking division or ratio or fraction. These are all similar words. So whenever I have a quotient, we can write it as log base b of m minus log base b of n. So for the product property, we added, and for the quotient property, we're subtracting. Okay, so let's condense this into a single log. This would be log of 80 divided by 16, which is just log of 5. Because 80 divided by 16 is 5. Now let's expand it. I'm going to make two different logs. Log base 2 of x minus log base 2 of 5. Next, we have the power property. This says whenever you have an exponent, you can move it to the front and turn it into the coefficient. So what this will now look like is n of log base b of m. This exponent came to the front to become the coefficient. And you can go back and forth. The coefficient can come back up here to become the exponent. You can go back and forth. Okay, so let's go ahead and condense. When I'm condensing, this 3 coefficient will become the exponent. So this will be ln of 9 cubed. So I know 9 times 9 is 81, times another 9 is what? 729? So this is ln of 729. Next, I'm going to expand this one. So this exponent of 2x will come to the front. So this will be 2x log base 7 of 3. The last one is the change of base formula. This is good whenever you have something complicated. Before I show you something complicated, let's do something simple. So when I have log base 8 of 64, this means 8 to what power would give you 64? So we know the answer is 2. However, let's say I had something complicated like an 18. Do I know what power of 18 will give me 64? I don't know off the top of my head. So in this type of scenario, change of base formula comes in handy. You can do log of A over log of B. So for example, this one will be log of 138 over log of 5. And you would just type this into the calculator. Log of 2 divided by log 14. Okay, now we're going to do a few examples where we're going to use these properties, okay? Okay, here's number 23. Okay, so first I'm going to go ahead and use the power property because I have coefficients in the front. So I'm going to go ahead and use the power property. So when I use the power property, this will be natural log of 64 to the power of 2/3 minus natural log of 8 to the power of 2. Because these coefficients became the exponents. Okay, now let's break down this one really quick. Off to the side, I just want to write this down. 64 to the 2/3 can also be written as 64 to the 1/2. I'm sorry, that should be a 3. This can be written as 64 to the 1/3 times 2. Do you guys see why? 2 times 1 is just 2, and you have 3 on the bottom still. Okay, so this is how it can be written. Now, when you have an exponent of 1/3, that is the same thing as saying the cubed root. This is the same as this. And don't forget the little squared. Now, let's evaluate this. Think with me. What number multiplied by itself 3 times is 64? 8 times 8 is 64. I need a number that multiplies 3 times, 4. So look, 4 times 4 is 16, times a third 4 is 64. So that means the cubed root of 64 is 4. And then we're squaring it. So this is just 16. So guys, this whole thing is just ln of 16. Next, we have ln, or natural log, of 8 squared, which is 64. And then we're going to use the quotient property here. This will be the natural log of 16 over 64, which is just the natural log of 1/4. So guys, something that you had to remember is that whenever you have a cubed root, that is the same thing as having a 1/3 as your exponent. These are identical. Also, a square root is the same thing as having x to the 1/2. These are identical, different formats, same value. Okay, next. Okay, so guys, again, we're going to use the power property, which means these coefficients will become exponents. This coefficient will become an exponent. So what I will have is log base 3 of a to the 3/2 minus log base 3 of 16a squared to the 1/4. Okay, let's deal with this first one. So this a to the 3/2, that is the same as a to the 1/2 times a 3, because 3 times 1 gives you this 3, and the 2 is in the bottom, in the denominator. This is the same as the square root of a to the power of 3. Okay, let's look over here. Over here, I'm going to distribute this 1/2 here, or this 1/4 to the 16 and to this. So I'm going to have 16 to the 1/4, and I'm going to have a to the what? Oh. 2 times 1/4 is 2/4, which is, okay, so this is 1/2. Okay, so guys, this is the 4th root of 16. What is that? Yes, this is 2. The reason this is a 2 is because 2 times 2 is 4, times another 2 is 8, times a 4th 2 is 16. Uh-oh. So the 4th root, this is supposed to be a 16. I didn't have space. Okay, so this is a 2. So let's write down what we have. I have log base 3 of a to the square root of, or cubed, minus log of this. Now what can I do? Quotient rule. They're subtracting, so I can do the quotient rule. So this is log, I forgot a little 3. This is log base 3 of square root of a cubed over 2 square root of a. Okay, I'm going to do one final thing. Let me expand this out. Square root of a times square root of a times square root of a over 2 square root of a. Why did I write it 3 times? I can eliminate one of them, but I wrote it 3 times because I have a 3 right here. This can cancel with one of those. So what can I write? Do you guys know what the square root of a times the square root of a is? Square root of a times the square root of a is just a. Because think about square root of 9 times the square root of 9. This is 3, and this is 3, is just 9. So it's whatever's inside. Let me back this up. Let me try to make this easier. Let's try to forget about roots. Maybe that might help you because some of y'all look a little stressed. Okay. Let me do, okay, actually, I think this is better. Let's do this. Is everyone good right here so far? Are y'all okay so far with this? Okay. All we did was move the coefficient to the exponent. Okay. So, guys, let's look. Now, from here, I'm going to apply the quotient rule. Let's not try to simplify things. I'm just going to do the quotient rule. Oh, sorry. The quotient rule, I only need one of them. Is that okay? Okay. All right. Let's try to simplify this sum. I'm going to distribute this 1/4. This is log base 3 of a to the 3/2 over 16 to the 1/4 and a to the 1/2. What did we say this was? 2. So this is log base 3 of 2. You had an a to the 1/2 here and a to the 3/2 here. Is that okay so far? Okay. The 2 because 16 to the 4th power is 2. Because this is that. Okay, which is 2. Okay, so let's simplify this. Guys, if I have a to the 3 over a to the just a, what is it? How do you know it's a squared? What'd you do in your head?
What is, yeah, oh, that's it.
You subtracted. You did 3 minus 1, which is 2, right? Okay, you could do that too, Nathan. But it's a little complicated when you have a fraction. So just like you subtracted here, you're going to subtract here. So guys, what's 3/2 minus 1/2? 2 over 2, which is just 1. So that means this is just log base 3 of a over 2. Y'all said it was 1, right? Okay. That's another way to do this problem. Okay, choose which one works best for you. Was it already paused?